Okay, welcome guys. So in this video, let's try to prove the Cauchy integral formula and the derivative. Okay, so let's assume that everybody knows about some complex analysis. If you do not know, then you can go back to see my previous video. So what Cauchy integration formula is basically this one. So basically, if you assume your f is analytic, so let's say f is analytic, and basically analytic, right, on some closed contour C. C may not be same C may not be this C, right? You should boundary C. Or okay, maybe I should use this as C. So C should not be not need to be a circle, right? But I just plug it as a circle. So and f is analytic at this place. Then f of z divided by z minus z0. So z0 may be some in or out. Okay, will be just fz0 if z0 falls into C. So if z0 are inside C, then inside is C, then this is fz0, then else will be 0. Okay, so this is Cauchy integration, and else to be 0, then I don't have to prove. Okay, so in order to prove this, all we need to know is there's a fact that if f is analytic, right, enclosed by a C, right, and f of z, then basically if you integrate along the z, C will be 0. So this is the proof. This is the fact that we will use. So this is the basically induced by the Cauchy-Riemann. And the reason is that one can just write dz as dx plus idy, right? F as u plus iv. So this will be just u plus iv dx plus idy. Okay, so if you write as c, then you will become u dx minus v dy plus I u dy plus v dx. And this is, one can solve this by just use a formula. Basically, it's a Green theorem. So Green theorem in the vector calculus will be partial q partial x, partial p partial y, and the dA and the along all integration with respect to a. Right. So you will get vx minus uy. Let me see. Vx minus uy. Plus I, right? So let's say this is v dx plus u dy, right? So you will get the ux, well, this should be plus, right? Because this is there's a minus term here, right? So get it here, dA, right? And from the Cauchy-Riemann tell you that ux equals to vy and uy equals to minus vx. Okay, so these two terms cancel. So you get the zero integral along with 0. Okay, so this is the first fact we are trying to prove. I think there's a there's a name for this theorem. I'm not sure. What is this theorem? What is this theorem? What is this theorem? Okay, yeah. This theorem also called a Cauchy integral theorem, but it's the first version. Okay, so I should say the Cauchy integral form. The first one is basically f is analytic. You integrate along C, that you get 0. Okay. Okay, so next, now we can prove a second version. So second version is that the consequence of the first version. Then after that, we will prove the third version, basically the differential form version. Not differential form, the derivative version. Okay. So now z0 is inside a closed C. Okay, and the proof is very simple, right? Because if I assume that z0 is the interior point of C, then basically I can choose a very small distance, a very small epsilon ball, right? And this z0 will this ball will fall into C. So basically, you would need to assume that z0 is the interior point of the of your region. So that means you can always choose a care for this ball, right? This cube ball. Okay, and I can say just I can let this just as a let's say this is a C1, right? So now let's say this integral is a, right? So a minus another 2 pi I C1, right, will be 0, right, by the first theorem, right? Because now z0, there's no other strange points from C1 to C, so all these regions are analytic, right? So from the Cauchy integral first one, we get the 0. From this one, okay. Then what should we do? Right? So, right. So, along C1, right, we can just directly compute this integration. I can just let so z equals to z0 plus r exponential I theta, right? So, okay, so I use epsilon. Okay, so this is just epsilon exponential I theta, and f of z0 plus epsilon exponential I theta, and the dz, right? Dz is just epsilon I exponential I theta, so I theta and d theta, right? D theta is here, so you can cancel with this epsilon and cancel with this. Then you get I fz0 plus epsilon exponential I theta d theta, and along theta to 2 pi, and you can take epsilon to be 0, right? So this term will be I f of 0 times 2 pi. So it's 2 pi I f of z0. Nice. So that means this integral is basically 2 pi I f of I z0 f of z0. So this one is just 2 pi I f of z0. So a equals to 2 pi I divided by 2 pi I. You just plug in this f of z0. So cancel. And what the definition is of a is basically this. Okay, so nice. Okay, so we proved the Cauchy theorem for the integral for the second integral form. Okay. Okay, so the next one, what I want to prove is the derivative form. Okay, so let's say the derivative form. Okay, so derivative form. What is derivative form, right? So let's say f of z0, right? Everyone knows about the results is like this. But how about this, right? How about this, right? If you just stupid this square is okay, and the proof is very easy, right? I just partial z0, right? Act on the both sides, or d divided by d0 both sides. So f prime of z0 is 1 over 2 pi I, and then you do the z0 differentiation, then you get there's a minus sign here, right? But notice that since when you do a derivative, you get minus sign, and then you get another minus sign as a chain rule, right? So there's no minus sign you get here. Okay, so let's. Okay, so this is the derivative form. Okay, this is the derivative form, and we can just easily generalize. We just keep differentiating, so finally you will get the final derivative form. So just differentiation with two sides respect to z0, two sides, and you will get z minus z0 to the power n plus 1, and n factorial, right? Because you keep doing that. Suppose you do another derivative, then you get another 2 factor, and the minus term is also cancelled by this chain rule. Okay, so this is our general derivative form. Okay, and that's it. And next time we'll prove another theorem called I don't know how to pronounce it. Borer's theorem. So next time we'll prove this theorem by just using this formula, and we will see what is this formula implies. Okay, so let's recall for today. So we prove Cauchy integrals, three kind of Cauchy integral theorem. Let me change the background. I just want to change the background for fun. Okay, so what we prove is basically the first one is that f is analytic in C. Then we have the first one is f of z, dzc, which is 0. And the second is what we have proved is f of z, z minus z0, dz is 2 pi I f of z0. Also a cute third form, f of z, z minus dz n plus 1, right? dz will be 2 pi I f of n derivative n factorial. Okay, so that's maybe I mean clearly, very carefully. So f is analytic. Which is on C. Okay, that's it, and I will see you guys in the next video, and be sure to subscribe to my channel. Thanks.